Hi, and welcome to another game edition with Nate Nestler for SDL. This is for Hyperactive Studios. Alright, so this is an update to what we had before. So what we're going to be doing is this is going to be an update to the actual joystick system itself. Now in previous videos we had the joystick system working great with Windows, but I hadn't tested it with Linux, and I did run into one problem on Linux that's not a problem on Windows, and that is the inability to be able to open and close the joysticks as you would desire. So instead you have to have your joysticks running concurrently on Linux, meaning you have to open up all your joysticks and then be able to read from them simultaneously and then close them all when you're finally done with them. If you close them, you can't open them back up again during the actual running of your game or whatever. You can on Windows, you cannot on Linux. So be aware of that, and that's because they use two different subsystems for joystick system. On Windows, it uses DirectX underneath the hood for direct input, and on Linux, it uses its own setup or whatever for the SDL for the joysticks. So because of this, we have two different systems for accessing the joysticks, of course, and one's on Windows and one's on Linux. So I had to recode the system for how it worked a little bit in order to make it work on both properly. I've also coded it up to work on Linux, and so this is the final setup here that works great on Linux. Okay, so you need to do an elif here with Linux in parentheses, and then do #include gl/gl lowercase gl dot h. This does need to be an uppercase GL. It has to be done just like this. GLU like so, and if you want to, you can do GLX also. Along with that. This is for other types of OSs that may need this set up instead. Okay. So with that, let's continue on a little bit more. I also have these set up here, if you don't have that already. And we have our good old vector joystick list, of course, and we also have the num of joysticks. So nothing real shocking here on a lot of this. Struct joy control here. Alright, so you'll notice that one is joystick and the other one is joysticks. Now I could have probably come up with a better name, granted. But you'll see what is what here in just a second. Alright, so you need both of those to find out. Okay. Alright, so with that, come over here and check it out. We need to resize joystick and joysticks to the number of joysticks that are on the system that we got in here. And then for joysticks, with the joystick name here, those are going to get assigned. And then we're going to open up, when we open our joystick, those pointers to the joystick that's open are going to get loaded into joystick itself. So that's the difference between the two, really. See if I can't show that better. Yeah, so you see this one's an SDL joystick star here, pointer. And so this allows us to point to the actual open joystick. That's open. This is our joysticks for our data structure that holds all our information about our joysticks here. And this gives a type joy control, which has joy ball as part of that. So that's the difference between the two, and that's why we have both. Alright, so every time we open up one of these joysticks, we still have to have record of where they are in memory. So that way we can access it later when we're getting the joystick information so that we can read it in. Because we are unable to close our joystick at the end like we were doing beforehand on Windows, that is not going to work on Linux, because the moment we close this joystick structure, we can't access it again. We can't reopen it. That's it. No more. So it's really important that we don't close it until the application closes itself, and in which case then we don't want the controller anymore. So I needed to point that out because that's really important. So we're now doing this joystick index here and assigning the open joystick pointer into that placement here as a vector, so we can just pull it up later. I'm using vectors here because I'm going to get very few changes in movements on a vector with a joystick. So we're not going to have joysticks getting added and removed on a regular basis. It's not going to happen much. And the vector is going to lay out the memory in succession. And since we're going to be looping through these a lot and accessing them a whole lot, it'll give us faster memory access. So we'll get better performance gain from that. If I was adding and removing stuff on a regular basis, I would want to put it in a list. But the downside to that list is that the memory can be scattered. So the memory doesn't have to be lined up in a row. It can be, but it doesn't have to be. So if memory is not ordered, where it's like, one after another after another after another in memory succession, then it won't be as fast when we go to access this over and over again. So the vector reorganizes memory to where it's, in succession whenever we move something, so that memory addresses don't get out of place. So that way we get a block of memory going across it, which means memory access times are going to be faster when we're accessing it. But that performance gain is lost, of course, if you are adding and removing on a regular basis, but we're not with a joystick. So it makes sense in this particular instance to use a vector. Okay, so joysticks here, .numaxes. All this stuff is the same. So really, let's have a look at what else has changed. Not much, really. Ah, yes. Had to change this. And my reasoning for doing so, well, it's pretty good reason, really. My reason I did this for a change was that on Linux I was getting about a 50 times increase in speed over what I was getting when I was on Windows. So I had to adjust for that. So I didn't optimize my Linux or anything. That was just the Linux out of the box. That's what it was running at, about 50 times faster for the application. So if I'd optimized the kernel or whatever, I could have sped it up probably about 2 to 4 times faster. And if I optimized the libraries it's based on, it would speed up even more. But regardless, that's about what I was getting in speed difference between without any optimization. With additional optimizations, of course, we would see higher speeds and performance difference there than what we're getting already. Because Linux is open source, we can actually recompile the kernel. We can't do that with Windows because it's closed source. So, we can gain some extra optimizations on Linux you can't do on Windows because of that. Alright, so here we go. We have our if here, Win32, if ABS here, joysticks, index, open close bracket, dot access here. And this is all good. So you see the values that I changed here. In the case of Linux, I had to do this number twice because it was going so unbelievably fast. I had to actually get it down, by that much, which is insane. And that's what I'm talking about. It's 50 times, difference there. This right here makes a 50 times difference. So it was just updating too quickly and too easily, and to a point where I had to really reduce the performance on it. It was just running too fast. And it's spinning like a top with that set to the same setting as Windows. So I broke it out and differentiated too. You may want to do that also for your game players too. Figure out what your variance is, or a typical variance, and then just do that as a default setting, and then someone can adjust it if they need to, but at least the adjustments won't be like sky high off. You know what I mean? There's a really big difference between Windows and Linux. Most of the time, most players aren't going to notice because they'll just have just the Linux version or just the Windows version, etc., and not both. But I broke this out just to deal with the performance variance between the two. Okay. And so I just did that real quick with the pound if here, Win32 for Windows 32-bit, if LF here for Linux, and I put in parentheses Linux, and then did pound, end if here to end that structure. And that's how you can program around Windows or Linux whenever you need to. What other setup I had to do? Oh yeah, one other thing. I also threw this in here for the heck of it. It's not really needed in my particular circumstance because I'm using a polling event structure, and I forgot to mention this earlier. Alright, so over here we have our polling event structure, and I've added to it significantly. I added up all the ways you can pretty much write the polling events for the most part for the joystick. The only thing I couldn't find was how to access multiple joysticks through the polling event system. So because of that, I have it commented out, and I'm sticking with my direct access system for that reason alone. But if you want to do a polling event system, this is how you go about it. But since I'm running a polling event system for the joystick, it automatically updates it without having to run an update function like this here. If you don't have that polling event system and you want just this function, then you absolutely need this update. So SDL underscore joystick update, open close parentheses, semicolon, is a must if you're not using a polling event system. Okay, so with that, for int index equals 0, etc., etc., all this stuff is the same. And then we're going to get down here to the end, past all this polling event stuff, and we'll close all our joysticks here. So check it out. That's what we're doing here. So I'm looping through all the joysticks that are attached to the system, and I'm closing them out one by one. I need to do this in order to be compatible with Linux, so I'm doing this at the very end. Of course, this works fine for Windows too. SDL quit here and return 0. And just as a proof that this does work fine inside of Windows, along with Linux, here we are. And then I'll throw in another video that shows it working in Linux. But there we are. Yep. So, very cool indeed. Over here, if you want to do the joy axis here, I've set it up to where I did my event system. So if whatever axis is being accessed isn't above 3000, I don't even bother with it, period. And then I do 4 here. I mean, it just depends on your setup. You may or may not want to do this. This could cause gaps or holes in your access if we do this. If you do need some kind of update, so you do know that, hey, there should be a 0 there, because then you don't know what access was accessed. Which axis was accessed until you loop through it and find it. See, and this is where we're determining, hey, which axis is accessed. If you want, you could switch it up above and then find out if it's above 3000 or not. As that may be a better way to program this, honestly. But I'm not really implementing it, so I didn't really care. Here's our index buttons here. Our num buttons here, index button plus plus, event.jbutton.button here equals index button, so on and so forth. Joysticks index here, dot button, index button, etc. SDL underscore joysticks get button here, index button. This might be a throwover from the other one, which may not be necessary, because we're finding out which button it is right here. So don't need to run the get button function here. That could be removed. but you do want to assign the particular button for your joystick to the according button here. So probably whatever your event.jbutton.button is for your, you know, if it's a match, that needs to be assigned here as a 0 or 1 coming up here for your access. This is a button down, so that would make it a 1 here for this particular index button. Yeah, you don't even have to do this. You could just say, as an example here, 1 dot semicolon slash slash would do it. Alright. Because that's button down, and it's particularly for this index button, so therefore it's going to be the correct one. That lets you assign and set that. Okay, so now that that's fixed, because you wouldn't want to use the skip button because that's the direct access method. I popped it in there and forgot to remove it. Oh well. Case SDL underscore joy hat motion here. This gets to our different positions for the joy hat. You can also use these exact same scenarios here for these ORed, also up in the direct method too, by the way. I just didn't do it, but you can do it. So all these different ones work. Like hat centered, hat up, hat down, hat left, hat right, hat left down, hat left up, you know, hat right down, hat right up, etc., etc. All those also are directly applicable to our direct input method for our joysticks. Okay, so with that, that pretty much covers what you need to do in order to update your program for your joysticks. So that way you can get your joysticks running in both Windows and Linux. So there had to be a little bit of code around there. Wasn't that bad. I had to rethink, and it was a little more complicated for doing storing all the joysticks into another vector here for their open handles, and then close them at the end with a loop. But that's wasn't that much really. It was pretty easy really. So I had to think about it for a little bit and had to change things around and figure out what was wrong and why it wasn't working properly on Linux. If you are still having trouble on getting your controller to work, and this code is working perfectly fine for me, but who knows, maybe your joystick's not compatible or something like that with the current SDL or something, I guess. You could try also going to, although SDL works with most controllers, so it's really rare for it not to. But anyways, you could go to, it's probably the this one right here. Of course, yeah. You could download SDL 1.3 here, like so, from the SDL HG download area. And they have even added, and this is really cool, they've even added on here the ability to go ahead and access force feedback in 1.3. So I thought that was really cool. And this is the home page here, and you can pay for SDL if you so desire, so you can get some extra features and functionality. And they've expanded it out to do some more stuff here. So here on our about, yeah, they have some more support here. They have Windows 2000, XP, Vista, and 7, Mac OS 10, Linux, FreeBSD, iPhone, iPad, iTouch, Android, Nintendo DS. So you can see you get a lot of extra platforms here. Here's the difference between the free one and the commercial license here. Customize source code, sure. Active community, open source development, commercial development, dynamically linking with SDL. Yep, you have that in both. But if you want to do development statically linking SDL, then you have to have a commercial license for that. If you also want to do iPhone and iPod development, then you also need a commercial license for that. If you want embedded systems development, you need a commercial license for that. Personal email support, so if you need personal support, cool, you can get personal support. That's awesome. Commercial license is required for that, though. Additional contract services, you need a commercial license in order to get it if you need special development. So there is support available, and so if there's something you need that's not working, you can get support for it and get something working that you need. But you have to pay money for the commercial license. And this is in beta right now, but it's pretty awesome. and it's really great to hear that they are getting force feedback, among other features here. They're also getting full 3D hardware acceleration in the new version and support for OpenGL 3.0 plus and higher. You know, support for multiple windows, support for multiple displays, support for multi-touch and gestures, force feedback available on Windows, Mac OS 10, and Linux. So really, really cool. Lots of awesome features there that are coming out that's not currently in 1.2. And this SDL is just getting better and better, and it's really great and it's awesome. And it's really nice to be able to have this kind of support across this many different operating systems and platforms, and be able to really do just pretty much whatever you need to do for accessing the systems and all in one coding, so that way you're not wasting a tremendous amount of time trying to develop your application. And so this really enables you to get things done in a lot easier, better manner and setup. Okay, so with that covers SDL update here for the joystick. I will put out another video here in just a bit for accessing and showing off the joystick working in Linux. No problem, but it should work on your Linux or on your Windows, either one. Shouldn't be a problem. Alright, so with that, this is SDL Update, and my name was Nate Nessler, and this is for Hyperactive Studios. Thank you very much.